Guys, good afternoon. Welcome back. This is the teacher Miguel, and today we are going to talk about comparing hard and soft water. And we are going to have a reading lesson. And let's start with the reading lesson. And after that, we are going to watch a video to better understand. And let's start. Okay, let's start checking the vocabulary. This is very important to check the vocabulary and the key concepts. So the topic is comparing hard and soft water. The objective is um, comparing between hard water and soft water. And the key concept that we have is when two liquids combine, a solid sometimes form and drops to the bottom of the liquid. This new substance is insoluble and is called a precipitate. A precipitate is the product of a chemical reaction. Soap scum, a common example of a precipitate, forms when certain minerals in hard water react with soap molecules. Let's to check the vocabulary that we have and is the key concept. So we have the crystalline solid, that is a solid with a near perfect arrangement of atoms, ions or molecules. We have filtration, that is a process for separating solids from liquids. And we have hard water, that is the water with a high concentration of magnesium and calcium ions. And lime scale, that is a white substance, mainly calcium bicarbonate, that forms on the inside of pipes and pans. Soft water, that is water free from dissolved calcium and magnesium ions. Another is supernatant liquid. The clean liquid left after a precipitate settles. And synthetic, that is produced by chemical synthesis. Okay, that is the synthetic. So let's start with the reading part and the precipitate and hard water. The precipitate are insoluble solids that are deposited from a solution after a chemical reaction or a change in temperature. Precipitates can form when two soluble salts in a solution react to form one or more insoluble products. The insoluble products separate from the liquid and is called a precipitate. The solids produced in precipitate reaction are crystalline solids, and they usually settle at the bottom of the solution. The fluid that remains is called a supernatant liquid. The two parts, the precipitate and the liquid, can be separated filtration among other methods. methods. Precipitation reactions can be used to determine whether or not a certain substance is present in a solution. If a certain chemical react with lead to produce a precipitate, for example, you can test water for lead by ending the chemical and sending if the precipitate forms. Precipitation reactions can also be used to separate elements such as to extract magnesium from seawater, and the most common water problem in the house is water with a high mineral content or hard water. Hard water contains ion of magnesium and or calcium, and if these minerals build up on pipes and the water flows through them, the pipes can become clogged, especially if there is a high concentration of calcium ions. These these deposits restrict water flow and can cause boilers to overheat. And seeing that you have hard water at home is the formation of a lime scale inside pans in which you boil water. Hard water also reduces the ability of soap and shampoo to lather. Soap Acum is the term for the sticky, grayish white precipitate that form when soap react with the minerals in hard water. This soap, this soap, this soap Acum makes rinsing very difficult. When you wash your hair or dish with hard water, while chalky scale or residue is often left behind. There are, however, some benefits to hard water. It often has a pleasant taste, and depending of the dissolved minerals, it may confer some health benefits. Home owners that have hard water often treat the water to make it softer, which involve replacing the magnesium and calcium ions and the water with sodium ions. The result is soft water. Soft water does not react with soap to form precipitate, but it also does not taste very good. The detergent such as dishwashing liquid and laundry power are synthetic soaps that are designed to launder in both hard and soft water. Calcium and magnesium salt in the water also react with detergent, but they form compounds that they are soluble in water, so no precipitate is produced. So let's do watch a video for the better understand, and we continue with the activity.
Hello, I'm Robert Kraft. This time we're going to examine the chemistry of hard water. Now, when I say hard water, I don't mean ice. Ice is solid water, but that's not what we're talking about. Instead, when we talk about hard water, we mean water that contains chemicals that contain calcium or magnesium, chemicals that interfere with the way that soap works. And to understand that, we need to know more about the chemistry of soap. Soap is produced by a process called saponification. For saponification, we take an alkaline, usually sodium or potassium alkaline, we mix that with fats and or oils, and that gives us a chemical called a stearate. For most bar soaps, like you get at the grocery, they start with sodium hydroxide, commonly known as lye. They mix that with fats and or oils, and that produces a chemical called sodium stearate. Sodium stearate makes a very good soap because it's a big molecule. One end of the sodium stearate molecule is attracted to water molecules. The other end of the sodium stearate molecule is attracted to oils and fats. And so it sticks the fat to the water. Because that water molecule is also attracted to other water molecules, it can carry that oil or fat away, and that's what gets things clean. The oils on your skin can cause dirt and things to stick to your skin, and by attaching to those oils and pulling them away, it releases the dirt and helps the soap get your hands clean. We want to see how that works, and to do that, we're going to start with a couple of jars. I always save jars whenever I use up anything. And in each jar, we have 100 milliliters of distilled water. We want to start with distilled water because we want to make sure that there's nothing else in there that's going to affect the chemistry. Just water. In one of those, I'm going to add some soap. And to do that, I took the bar of soap and my knife and I shaved off 1 gram of soap. I'm going to put that 1 gram of soap into this container. There we go. For the other container, we're going to turn this into hard water. And for that, we need to add either some calcium or magnesium. An easy way you can do that is with Epsom salts. Epsom salts is magnesium sulfate. And so that will give us the magnesium. I've got 2 grams of Epsom salts that I'm going to put in there. We will give this water a quick shake to dissolve the Epsom salts. And it probably won't all dissolve, but most of it will. There we go. And then we will add another 1 gram of soap flakes. Put that all in there. Put the top on both. And then I'm going to shake them both for about a 10 count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can see a lot of difference. The soap and water, just by itself, produced lots of foam. That sodium stearate is hooking onto the water molecules, and that helps it form the bubbles for the foam. On the other hand, in our hard water, the sodium stearate didn't do that. And that's because the sodium in the sodium stearate was replaced by the magnesium from the Epsom salts. And that formed a chemical called magnesium stearate, commonly known as soap scum. The magnesium stearate doesn't attract water, it doesn't attract oil, it just clumps up and sits there. And so it forms this white solid stuff that's sitting there on the top of the water. This is the soap scum that sometimes forms a bathtub ring. If you happen to have hard water at your house and you use bar soap to wash with, you probably get that layer of soap scum around the edge of the bathtub where the water is precipitated out, that magnesium stearate. All right, so we can see that hard water does not foam nearly as well as soft water, water that doesn't contain the calcium or magnesium. But there's another thing we want to look at, and that is how they deal with oils. And to do that, we'll take the top off the 2, and then we're going to add some cooking oil, just some regular old vegetable oil. I have 2 milliliters of vegetable oil in each of these test tubes. So we'll put 2 milliliters of oil into each one. Put the Pops it back on again. Again, shake them for a 10 count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we don't see a whole lot of difference. But now we're going to test it. And to test it, we're going to use some brown paper. Got some cotton swabs. We'll open the soft water. And on my paper, I will put in S for soft water. And then I'll put in H for hard water. There we have them. Take one of the cotton swabs and I'll get it down into the liquid part down in there. And then I'm going to rub it in a nice circle here above the S. The liquid soaks into the paper and makes sort of a dark spot there. Put that one aside. Top back on that so we don't make a mess. Then we take the other jar, fresh swab, stick it in there into the liquid, and then we'll rub that here where it says H for the hard water. And that also makes a dark spot. And we're going to let those sit there until they dry. You may have to let it sit overnight. But what you're going to find is that the dark spot for the soft water is going to mostly go away. It's going to evaporate and just leave maybe a little bit of a stain, but not much else. All of that oil has been bound up to that sodium stearate. With the hard water, the oil is still there. And if you get it on your fingers, you can feel that it still feels oily. And so this is going to leave a dark stain that will stay there. That oil's not going to evaporate away. It'll still be there tomorrow. But we want to look at one more thing before we move on. We've got these two examples. We want to look at one more example. And for that, we're going to use some liquid hand soap. I want to measure out, turn on my scale here, set the jar on there, hit the tare button to reset it to 0. And then I'm going to add 1 gram of soap, just like we added 1 gram of the bar soap. There, okay? So now we have 1 gram of soap there. In this water, we're going to put 2 grams of Epsom salts to make it hard water, just like we did before. Give it a shake. 10 count. 5, 6, 7, 8, 9, 10. And then I'm going to pour our hard water in there with that liquid hand soap. Now, we saw with the bar soap that the hard water formed soap scum. Let's see what happens with this soap. Again, we'll shake it for a 10 count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this formed foam even in hard water. How did it do that? Well, this isn't soap. Even though it's labeled as hand soap when you buy it at the grocery, this is actually a detergent. And detergents are a different form of chemical. Instead of being stearates, detergents are usually sulfates or sulfonates. If you look on the label, this one is sodium lauryl sulfate. And detergents aren't bothered by the calcium or magnesium, so hard water doesn't interfere with the way detergent works. I can add in 2 milliliters of oil, just like we did with our other two. Put the top on. Again, shake it for a 10 count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we will put a D on our brown paper for detergent. Start with a fresh cotton swab. Get it down into the liquid there. Nice wet spot there, just like we did with the others. Let that dry, and what we will find is that just like the soap, which has now almost all evaporated away, the detergent will also almost evaporate away. So the detergent foams and gets rid of fats and oils, even in hard water. And that's why people that live in places that have hard water are mostly replacing this with this. That's also why we use dishwashing detergents and laundry detergents, because they work even if we're dealing with hard water. So, you want to learn some about the chemistry of soap and detergent? Get yourself some jars, some soap, some oil, some Epsom salts. Do some testing. Play with it and see the difference between soaps, which are stearates, and detergents, which are sulfates or sulfonates. And see what happens with hard water. Well,
Okay, guys. Well, we have some activities that we need to answer in the virtual class, sorry. So we are going to check this activity for the virtual class, okay? Thank you very much, guys. I hope to see you the next class.